Okay, so my goal here is to complete these two to-dos that I left in the quote-unquote self-image layer. This is a little trick I threw together to get the Magic ID system working. And now I'm going to go and factor it out in a more clean way. You can see it contains operating system level uh, switching in the code right now because it's using features that aren't in my base layer's OS abstraction. And so I was thinking about where these new features belong. Should they go into the self-image layer as an abstraction portion of the self-image? Should they go into the existing OS abstraction or something else? And I think that putting them in the existing OS abstraction makes the most sense because as I was thinking about it, I realize I already have OS library as a concept, and that is, if we look at the Win32 implementation portion of the base layer, that is using load library W. And we got that pulled up right here. And if you take a look, there it is. It's an H module. H module, that's the same thing we're talking about right here. In other words, at the level of the Windows operating system API, we're talking about the same thing in both cases. We're talking about a handle representing the loaded image of an executable file or a binary file into a process, right? Um, these names get a little confusing here because the data lives in a file and the file is a binary image file. But then when a process is created, the way the program gets set up is a space, an empty space gets created, and then stuff gets put into it. And the stuff that gets put into it is essentially basically a copy of the file. It's not that. There's a little bit of rearrangement of the data that happens. Some of it gets eliminated and some of it gets rearranged. But a copy of the data essentially gets placed into the process from that file. And we can read that data and parse it if we know where it is. And that's what we need the operating system to do now is in addition to being able to load libraries and get procedures out of them and release them, I now want to be able to go, okay, can you give me OS lib, image range? That's pretty much it, right? That would be what this part is doing. Now, the only other thing I need is a new helper thing that can help me get the module of the current calling code, right? If I'm writing some code that gets compiled into a DLL, I want that DLL to be able to write a line of code in its source that just gets the right library handle for itself. So these are the two things that we're doing here, 1, 2, and we just need to expand my operating system abstraction to have these two new features, and then the rest of what's here it doesn't need to be hashed out like this. There's still a second step, which is the decision of whether to use PE or something else, which is actually operating system dependent. If we're on Windows, in this case, that means we know that we're dealing with PE because that's how it works. But that's a little bit different. That's the parsing code. But these two concepts here are going to be transformed into this first. Terry's Python asks a really good question to explain this. What's the idea of the self-image? The idea of the layer is that it deals with accessing, and we're probably going to get rid of the layer by the end of the day, or rename it as it's only going to have half the same meaning. But right now, it's about accessing information that is in that image that is loaded into the process, right? If you write a program and there's a program file that gets loaded into your process, usually you don't stop and manually read that program data. Your program just runs. But I say I want to read it. And I'm not going to modify it. I'm not going to change its flags or anything. I'm just saying I want to read it. I want to parse myself. And in this case, what I wrote as a helper function was just the ability to say, hey, give me some data. You can create global data in C, and access it, and that data can be in any data section you say. So then you can organize your data into sections and say, give me the range for this particular data section. And that's what this is doing. Well, the range U64 here is a pair of pointers, essentially, which I could be the way I could do this. This is a data range in a different sense than this. You know what I'm saying? I want to actually think about this. Yeah, this is... I think this is wrong. I think what we want to do... What am I using this for? Range there, there. There's where it gets created. Gets used when we use section by name. The count is... Okay. We grab that and turn it into a pointer right away. So that is a... integer subtract. So here it's treating them as integers. Here it's treating them as pointers. Although I guess here it's integers again. I guess range U64 is okay. The problem with that though is that it isn't going to work for 32-bit. I've never had to do this before, and I've always avoided it, but I think this is maybe the very first time that the argument for it feels strong. I'm just debating about the naming scheme here. I think this is the one I like. Okay, now somewhere in my base layer early on, I'm pretty sure I figure out like if we're 32-bit or 64-bit, right? Adder size, there it is. Yeah, so that's called adder, so we'll go with adder. I usually just avoid setting stuff, something like this up because I've had so many cases where it ended up being a mistake to not have a fixed size. But for this particular kind of purpose, what I want to do is to use integer arithmetic, but inside the space of the current process's virtual address space. And not in the way of like just to simplify what could have otherwise been pointer arithmetic, but because I'm sort of parsing it, you know? That's the key difference. And using void pointers or U8 pointers is an option. But having them as integers has certain advantages syntactically. On the other hand, it could just be a pair of U8 pointers. Yeah, okay. I'm gonna go with that instead. Just I remember hating going down this road before. So I think this is gonna be better. Let's call this a range, not a range of pointers, actually. Let's do range adders. Range U64. Range adder. Except I don't want voids, I want U8s. So this is just range first. That's opal minus first. That's all good. Range of adders. Section by name. That's good. And this is range of adders. So this is pointer arithmetic. And this is int from putter first minus 1. That seems to have done a minimal amount of complexifying and decomplexifying. It's all kind of held standard. Yeah, one pass less. Okay, so that means, well, I'm not building anything with magic ID in it right now. I'm building PE table. In order to test this properly, I would need to go check out RPG Simulator while I'm working on it, because I don't have an initially available test case unless I went in and set us up to work on the just main.c testing space. Okay, let's do that. Main.c lets me test out stuff in my code base, so I'm going to come in here and turn on that for the build. I can turn off the PE table stuff. What do we got going on here? ASCII test? Okay, you're out. We're not doing ASCII. Actually, let's keep that in. We don't need PRNG right now. What we need is, we don't need the ASCII tests. We want, Mr. Forth self-image.h. Let's see, RPG Sim has this set up, so I'm gonna go grab it real quick. Self-image. Stream CB self-image base stream ASCII self-image C. Okay. I don't think we're doing buffer operators right now. Okay, so there's us building main. Oops. Back there in the main code base. Okay. And now we need to, let's test out and see if I can actually set up magic IDs. I remember how to do that by just looking at the id.h. How does it work? Not remember exactly. Let's see. I think I have to include the id.def.h, include Mr. Forth id.def.h, and define id enum name. Right, I have to make a new enum by going define foo family underscore sec name. There we go. And then all right, do something like that, usually. And then you build. Right, and so now you wonder, something like, where are my foo family here's the foo, where's my foo family's image or section? Get section by name. Foo fam. Then we print out this is just a test that we're actually able to get addresses. I didn't change the run function yet. That makes sense. We gotta set it back to, oops, not this one, this one. All right, that looks like what I would expect. You know, there's 3 of them. That matches this. Cool. Now, we can use that starting point to apply this plan to refactor. In my OS, or in my base layer here, I put in the idea of string 8 OS lib, what is it called? OS, yeah, I want that to be a straight range adder like the other one. Now we're ready to go take that into the libraries section. All right, base.c libraries, here they are. These are the ones to implement. So this here is how we're getting our module. We got to think about this. This might actually be a little bit tricky because we got to come up with a way to get this. Which means this one actually cannot be linked. It has to be local. Unless you pass the void pointer in from outside the same way you do with this one, right? If you wanted to, you could say something like that. This just just kicks the can down the road, but maybe down the road this problem will go from hard to easy. The alternative is that each binary promises to always build this particular symbol. And right now I haven't set things up to have a way to say that that might be allowed. Like here I did it with the global variables. But the way we include base.c and when we include it isn't going to work. I know there are spots here where weird stuff happens with comp time, and that's not zig comp time, that's compile time symbols. Although apparently not. What about like for the error system though? I thought that's how this worked. I thought there was a whole... Oh. These are not just linked, they're dynamic. I see why they're different. Gosh, I gotta get a handle on this still. This isn't quite the way it should be. Okay. And then this gets us into there. So what I'll do for now is I'll just do this pass the adder thing through thing. I don't know if this abstracts well to Linux or not. I assume there's probably something equivalent, although this might not be the ideal way to abstract it. It might be possible to just do like a compile time function that's very small for each operating system that serves this purpose and not link them together. But we'll figure that out down the road if that's something we want. OSLib from adder. OS library is the result, and the point is that the result is just an H module cast to a library like this. So I figure more or less we want to just do this. And now this one wants to read wants to read the address range from a module. Module info, I guess, makes me a little curious. How much is actually in there? Do I want to store more? Base, the size, comes with an entry point. That seems to me like extra that I don't care about in this sort of situation. So this just comes from this, but we just do get current process to get that. Get current process, read the module info. Now we don't have a H module, we have a OS library pointer, but those just cast back import like that. We grab the module info, and then the result dot first is module info dot lp base of DLL, and result dot one pass last is result dot first plus module info size of image. And I think that should be good to go, except we are going to need to go and grab a new header and put it wherever the windows.h is going. Like so. Okay, so you're not going to need to do that anymore. You're not going to need to do that. We're just going to read an OS library. From adder, we'll use the address self image get section by name. We know that's still local. Now, if this lib did not come out as a 0, then range adder and then that's this part. So this is this lib range dot first. This is opal minus first. And then the result is a sub-range that we figure out that way. Okay, so that is step 1. Now, interestingly, all of this is still like this if OS Windows, because this is where we decide how to parse it, and that depends on what kind of image we think it's going to be. All right. So maybe there is a point to having this bundled abstraction layer here. I could learn to live with it. But I still think that it would be better if this eventually got pulled out into a layer of its own, so that anytime we have a data blob representing an image blob data, like one of these PE files or any of the types of images or binaries, that we'd always have a way to parse it. I need to come up with a stable term. Any of these binary formats, whether in file or image format, gosh, it confuses me trying to say it out loud. So anyway, now that leads to the question, well, yes, I think I do want them bundled because of the fact that I always am going to have this sort of double dose of differences. The first dose is handled by the OS abstraction layer, but the second dose is just a dispatch on which file format I actually need to parse depending on the operating system. And I think that's what the self-image layer is providing. Is it's going to bundle in the idea that when we access our self, there we can bundle that with a specific operating system switch here. Although the hard part is, like, really you're probably going to rewrite this for different use cases all over the place. This is the thing for when you want to get a section by its name without any previous work having been done at all, right? It's interesting. Some other ideas are going through my head now too about how this all figures out. So if I want to keep this, then I still want to extract this code to somewhere else. And now the final question is, where does self-image actually going to want to live? Right now it lives here at the same level as all the other new ideas, but it feels like it almost belongs with the binary tools. But it has the quality of being an abstraction layer. which is fine. So it just wouldn't live in PE or ELF. It would live at the top level here. It'd be binary slash self image. And then, you know, it'd be like PE parse or something. I think I'm down for that. Okay, so this one's going to be a little different from the self-image version because it's not going to operate on the assumption that its addresses to its own self, so it's already different. It's going to be something like better. This is pretty much boils down to PE section header from name image name, right? This is basically the idea. All of that goes in there. Every occurrence of size is image size. Every occurrence of data is image stir. The bottom, second name and name compare. Oh, every occurrence of image.sizeof is actually a size of. Guess I need to go double check all the image.sizes didn't turn out to be goofy headed. Okay. And the image.stirs, are any of those goofy? Okay, that's fine. So parse can do grab that stuff. And then you get a match if you can, and you return it. And that's just a pointer into this data block that you originally gave with a section matching that one. Very direct. And self-image is now just bundling Oops, I did a little bit too much, huh? Give me a copy of that, and then we backspace our way through all of that. You go away, you go away, you go away, you stay, you go there. PE section header, section equals, PE section header, from name. Here is the image, here's the name. Here we go, instead of calling it the match. Something like this, the section. Oh, parse doesn't exist yet. Right, we got to bring in Mr. Forth PE parse now. And parse.c as well. Okay, so that's all working that way now. Okay. Not bad. Okay. This is a fine start. I'm going to put down some to-dos regarding this concept of self-image and the trajectory I'm foreseeing for improving it. know what? I'm not even gonna write this one as this to do. I'm gonna just apply this cleanup. I think what we're gonna do is, instead of thinking of this as the self image, how do I want to put this? All I want this to do when I'm done with it is start from here. So this whole bit will be excluded out, and then the only thing that'll be happening here is an operating system implementation for which section, which image type to parse with, right? So under the hood, these can all be slightly different, and then this layer will be the spot where if there was a concept that I was building with that I was thinking about abstractly as working across operating systems, that I'd put it here, and I'll maintain it that way, right? So then this gets pulled out. This becomes more like this. Okay. Okay. Okay, now the issue is that because I haven't already made this very simple, it kind of sucks to get the image, right? So maybe I want to go and actually do that first. The idea would be, ultimately what's going to happen here is there's going to be something like in Mr. Fourth base.h, comp time. Yeah, it's going to be something like this. But it's not going to be this. This is going to be like self-image layer or something. Maybe this needs to live. No, I'll put this here next to libraries for now. I'm not quite sure how to think about it yet. But it's a compile time symbol that looks like a range of addresses called Actually, let's make it a string 8. It's even better. A string 8 called I don't know. I don't know, just call it image here. It could be something like Mr. Forth this image or OS this image. I think that's the good way to call it. I'll call it OS this image. And then what happens before main. Give me an example of using before main. I gotta reconsider this. I don't love the way that looks. But I think what I could do is go in here and say init image specific global variables just right here. And we'll do this whole thing. Down here, after we've loaded in all the stuff from the base layer, we'll then know how to base before main. This is define runtime symbols. This only runs for things that aren't the DLL though, so maybe I'll go up to libraries. That doesn't abstract though. So man, where does this trick want to live? This is all super new. Here, do I stick it up with the global stat constants like blah 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 blah. Not these, not these, not these, not these. These. And this just goes Mr. Forth self-image, right? We're just counting on that to be ready. That is kind of a risk because these are also before mains. So it might not work. Ugh. Oh wait, no, it's self-image this is the name of it. This one should work because it's this one also needs it. I think I should just avoid the issue and change approaches slightly here. We're going to say base layer instead of this, because I can't control when that gets filled. And so there's no way to assure that that gets done before other things that want it, like those other auto init sequences. I'll instead choose to factor this as a member of the OS layer. But I'm gonna section it off separately. This is implementable functions self-image string OS self-image this void. And we want to note here that this is always with Win32, but it's supposed to be the case that you always compile this function in. And so I have only one way to achieve that right now, which is to put the definition here, which goes against how I normally do things, but I just haven't built the header C separation in a way where I have a way to do this yet, I don't think. Or if I do, I don't remember the rules. Like, yeah, these just get blopped in here. So if they're compile time symbols, what's the default? Yeah, they're link time, so that's good. They're not dynamic. I guess them being dynamic is the only thing that would be a problem, though. Actually. Yeah, no, I've overcomplicated it. It doesn't need to be comp time. It just needs to not be DLL link, which I don't think is a danger. I don't think there's any danger that it will be a DLL link. So this just becomes this. This just does this. that should actually be good enough. Okay, cool. Okay. So the reason I was overcomplicating that is because I was worried about the fact that I need to pass this address. And if that address refers to this function and that function were to be in like a DLL instead of in the main executable, then they wouldn't refer to the right spot. But this actually isn't saying that it's linked to a DLL. The only ones that are linked through the DLL are these ones that are more complexly linked up. And that's to avoid them having multiple copies of the same global variables when you link them together, like multiple DLLs using the base layer. This isn't that. Every module gets its own full copy of all this code at link time. So OS this image is therefore easy to make. It just points to itself, and you just make sure that it always gets statically linked into each exe and DLL separately. So it can do this part differently. Okay, so there we go. That's close enough to what I had in mind. I don't initialize it as a variable now because of the order of before mains being undefined. All right, so that's all the stuff with self-image that I've got going on right now. Now I want to get back to binary here. Okay, before I do any of this, the other thing that was bothering me earlier where is pe.table? That's for build. I actually want to change what I'm running. Right, I want to run pe table again. What was bothering me earlier is that a tool like this is cool, but a lot of my times I make these little tools and it's a pain in the butt to activate them because they're built in the base layer and they don't actually aren't actually in my path in any ways. They're not available to me to actually use for other projects I might be in, right? So I think next I will go deal with that path thing for a second. Let's go do that. So I have stuff that's in my path. Let's just explore how my system works. I've got this, I can go boom, and now I don't have Visual Studio in my path for some reason. I make myself type this, or CL setup, or setup VS. That's how I do it. Okay, setup VS. And then I'm good to go. I've got a CL compiler, all that. But before that, I do believe it must have visited what is the name of this? Is it in C? Bin now? Looks like it's all living over there in bin, right in my C drive. So this would be cdc, cd bin. No, cdc colon cd bin. Yeah, so that's how I'm able to run forcoder, git bash. somewhere along the way, C:/bin got added to the path, right? If I echo out my path right now, then presumably somewhere in this string, I should find C:/bin. There it is. Just before all the Visual Studio stuff starts, but after all the default Windows stuff. So since I can run, I'm kind of reverse engineering this system of mine. So it must be setup vs is available because I've already run the setup batch. And which one of these is that? It doesn't look like any of them are the setup batch, actually. Maybe fq.bat? I'm going to have to go check this. Okay. No, that doesn't mean anything to me. Okay, so if it's not in bin, it might be living right here. Start in Mr. Forth. Run, normal window. Advanced. No, so that's not doing anything special. So this must be like, oh, I forget where this is. Is this like startup? Init? It's like a batch script somewhere that you can do this stuff in. What is that called? Windows startup batch edit path permanently. Maybe that's how it's being done. All right, let's see what happens here. I don't really want to set the path variable though. I want to figure out how I did it. I'm pretty sure I didn't do any of these. And if I did, I don't know how to see them now. Edit path permanently 32. Okay, same spot as before. This seems like this has to be the advanced quote-unquote tab. Performance settings. No. Environment variables. Here we go. Yeah, there it is. I have been in there. A little VM in there. I'm gonna add in a new one because I don't want to pollute bin with it. This is gonna be bin temp or something like that. Okay. Okay. There we go. Now, I should be able to create a new folder called bin temp at the base of my computer here. In my bin folder, I'm going to set up a new batch file called bin temp save.bat at echo off, which is essentially just going to copy the input. What's an example of this where I might have... I didn't anywhere. I think it's like this. To C:/bin temp, right? I'll also make one called bin temp clear.bat at echo off. So say I've got bunch of files living in bin temp. How do you do the... no. Let's do Windows batch delete all files in folder no query. Good idea. Prompts for each file first. Delete specific files from all superdirectories. There we go. /Q. So this will be delete everything in bin temp. Don't worry about asking. And that looks like bin temp clear. It's empty. And then if I pop over to and I want to bin temp save PE table, build /PE table, what happens? What do I get over there in bin temp though? PE table.exe. Perfect. Okay. So now I can just point it at a file and get a copy of that file stashed into the bin temp, and then because I should have that in my path, the only thing I have left to do is I have to reset forcoder, but I should be able to PE table. Okay, that did something obviously. PE table build /main.exe test.exe. That didn't do anything, so it might be crashing. Oh, do you know what else might be happening here? We might be needing to do bin temp save build /Mr. Forth base DLL before we can actually run PE table. But there we go. Now I can just start spitting out utilities, and I don't have to worry about where they landed in the larger set of folders. Okay, that's cool. I like that a lot. And now launch forcoder, and we're still doing that, which is great. We can now go back to PE table. I know there's a bunch of to-dos here. The first one that I want to get to today is a bunch of these say they want to be right aligned. So I'm going to just go and introduce that possibility in the ASCII layer and call it a day. I think I'll call it a day there when that's done. So grab a cell. We're going to go table, cell, flags, type def, U32, table, cell, flags, enum, cell flag, and the first one here is going to be right align, which is the number 1. I'll also throw in a center, which is going to be a 2. And then I think for this it's going to be better if I do it this way. Left align, right align, center, align, align mask. Right, so that'll be how we get started here. And when we make a cell, it'll default left align, but we might want to change the default sometimes, so we can go like table align, table right align, switch back to left align, right aligned, left align, I mean, I can do it this way. It is a way to do it. Another way to do it would be to attach it to the cells. So cell align, right? And then I could always also do both. So it takes one call in a case like this to get what you want. And that just applies to the last cell. And then you can also change the table default for the alignment. So you can hit all of these at once. If you don't do this, then what you end up with is each of these gets one of these, which is a lot more crufty. Another option is that flags are always set on every cell. that might look something like this. Before the format string, right align. Then we got to go through and add left aligns everywhere. That kind of feels huge too. Yeah, but these are flags, so like future ones are going to be like, you know, what are some other ideas I've had for cell flags? It's questionable whether or not I want this, but like, no wrap or no new line, something like that. And then this would be like this. It'd be like these are the first 2 bits, and this is the mask. But I'm writing them in hex because like I might want to then go like this, you know. I guess I just like writing flags in hex because it like works better. It's not perfect, but it works better because you learn how to treat each 4-byte nibble or 4-bit nibble as one of the characters, and then you know which, like, you can start to just power the bits that way, right? That's why. Hey there, Jax Builds, welcome. All right, so that's out for now. I think the best bet is to modify the defaults and then have a way to set a single cell as well. Just go for that. So the table will now have a table cell flags cell align, which will initially be 0. Now when we create a table, we create rows that way. We're gonna set up here the stuff for setting table default. Set table cell align default align. Then after being able to create cells, you want to be able to modify them with these. Okay, so begin table cell align equals align masked with table cell flag align mask. When we create a new cell, we'll set the flags equal to the table cell align field. But if we want to reach into the last row, and then in the last row get the last column, the last cell, and we're able to get one, then we should be able to set that cell's flags to be equal to whatever they already are and the exclusion of the table cell flag align mask, or together with align masked that way, right? So here we're grabbing this portion of all those, everything in the flags that wasn't in the align mask, and everything from the align field that was in the align mask gets plopped in there in the flags on that cell. And I guess we'll call this just default flags actually. And we'll update it the same exact way. Default cell flags will actually not just get full set by this thing, but it'll go through this sort of bit bit set splitting thing. Still have to do this. I launch this. Jax, I'm not building a compiler. I'm curious though what I'm doing that gave you that idea, because I am doing like toolchain adjacent stuff. So if you're thinking about the object files and how they're related to compiling, then I see what you're thinking, but I'm not quite at the point of building a compiler. I'm doing some other stuff with it. Okay, so where are we? What are we looking at here? We're looking at. We don't know what to build. I want to be building PE table again. Cool. Well, that doesn't do anything yet because I haven't done anything with it. So now we got to figure out when we're coming in here. Right now what we do, I never did collapse the table implementation down, which is good because it would have meant I'd have to figure out my place a little more carefully. Right now it's this spot. Here, this is where the assumption is happening on the alignment. Cell flags and mask, and then these are the cases. So case cell flag left align, right align, center align. And since there's a fourth unused case, I'll just let that safety fall through on the default here for now in case it happens. We don't want to have the table becoming out malformed because of it. Now, what I'm going to do is I'm going to have to figure out x0 equals x, x1, let's see here. I'm gonna need to figure out several. So we're gonna do x0 equals x, x1 equals x, x2 equals x, x3 equals this thing. Then if we're doing left align, then we want x2 equals x1 plus, well, whatever I do, that's going to be the case. So this one can be left empty. X2 is always going to equal x1 plus the cell string size. So that one we don't need up here. But x1 is the interesting one. That's where we're going to get an ability to right align. That's going to be x3 minus cell string dot size, and an ability to center align. So for center align, what we need to do is say that the left padding is half of the total possible padding, so that x1 equals x0 plus x3 minus x0, that's the total size, minus cell string size, that's the space taken up by the string. What's left over after the second subtraction are the number of extra bytes we have, and we divide by 2. So if I have 3 extra bytes, what's going to happen is this will be 1 bigger than x0. So it'll put 1 byte there and leave the other 2 bytes on the end. But of course, there's something like combinable here, right? Because that factors like this, which seems to suggest we could just write this. This, x0 plus x3 over 2 is the midpoint, and then if we subtract that much, yeah, that seems good to me. That seems right. And then x2 gets set after. And then yeah, we want to do all of this if cell doesn't equal 0. So what'll happen is if we need to, we'll always just fill to the end by the end. So this is fill to x3 with spaces. Then what'll happen is there'll be a spot right here where we fill from, we start off at x0, we fill until x1 with spaces. Then we fill this spot and we increment. That should get us to x2. And so we don't need an x2. Okay. I'm going to switch these out with names. that should do the trick. Boom, alignment of the numbers. Let's also put in centering on the columns real quick. For that, we'll just set the default align to be center align right here. Set it back to left align up here. Amazing. Okay, cool. Cool. These have been set up with read-write permissions, and this one with read permissions. This is the one we could, in theory, eliminate someday. These are all protos in my new RPG simulator, but this one is an event. And I'm actually surprised to see that there's no sign of another one for the modules. I thought modules also had a parallel enum space, but maybe they don't. Maybe they share the enum space of the event or something. Or maybe they didn't get an enum space at all yet. Or maybe I accidentally didn't change the name on them. Let's go check it out real quick. Side projects, RPG sim, source, new, context, combat. So module def is a thing. Look at that. It is a bug. This should be something like that. And if I were to pop in and run the build, oh, right, these are different. You're gonna want to update to this. There we go. So that's back to running. Then this should show that. There we go. There we go. Bug fixed. That's the new debug feature. I can see my sections as I create them. That's the whole point. Okay. This is all cool. I got the thing there set up so I can actually run this to I can stash utilities to use. I have the PE table stashed for use. And so I should be able to start using it from the RPG simulator to look at what I'm doing. Now, I haven't decided yet whether or not to go ahead and do more with the object file stuff right now. If I were to, the next big step would be to build out this linker thing. But what's happened is my other goals are wrapped up in a day here. I abstracted and cleaned up the self-image layer, figured out how it's actually going to work. I got a tool up and running so I can look at the table of sections for now. And to get all the way to a linker from here would be kind of a big push. I think it would be a change to a different project that would take a while. Even just getting some like mini linker tech up and running, like the OBJ from Raw, would be kind of tough. And some of these other stretch goals, like the tech for editing out the Magic ID sections and gathering data back together into a single spot inside the object file before sending it to linking, these are things that are going to take weeks of iterating on them, probably. Because I don't have a very well, each one is quite a new kind of concept. Directly editing the relocations to fix up these changes is the interesting and intricate part. Um, and then once that's in place, there's the like tentatively testing out and looking for edge cases, making sure I've really figured out how to do it. Um, and I have the option now to back off of this again and call that good. Like there was a dip back in to get just what I needed to keep moving forward with the RPG simulator, and maybe I can go back to that. Let me think about where that project is at and what I'd be working on soon if I were to be working further on this. I think. Okay, so there's a way to. No, that doesn't. Yeah, never mind. I thought I had a way earlier. I was talking about how there might be a way to make the object file parser more reusable than I've done before without having to increase the cruft. But the basic fact is, my current way of doing the C scripting thing is deeply underdeveloped. There's very little in terms of help to make that less of a huge problem. The C scripting thing involves running functions before main. It involves having some kind of data structure that you build in main out of the loosely constructed information you gathered from the declarations. And I don't want to have to initialize a parser data structure in main just to use it. The reason I would have to do that is because of the way C works. I don't have any way to explain how to initialize it unless I bundle it in with the main code path of logic here. There's and if I put it in a before main, then it can't be guaranteed that it runs in the right order. So you only really get one phase of declaration, or you only get one before main phase, and if you need declaration systems, they all have to be in the before main phase, and then main has to do the work. Now, I could change that in this one by manipulating the data section further, but I couldn't change it in Linux so easily without further, like the GCC compiler in general, or the Clang compiler, I mean, even that I'm using on Windows, doesn't let me specify the section and manipulate them when I'm setting up the functions that are to run before main. I do it a different way, so I don't think I know how to take control over the order there. So I don't think I have any ideas on how to parse it, how to make the parsing code more reusable while serving all the different possible styles of parse. So, if I were to go back to this, I think the next big step with the RPG simulator is going to be to build out another minigame besides the combat minigame, right? This game has a little combat system set of rules, called a module, and I think I already threw in, even if I don't have them. Yeah, I've got a sketch here for a new one that just hasn't been fully implemented and put into the game yet. But I was starting to think about how I would build a second one and how I would actually handle the flow of logic between these module things, and if that's the entirety of the description, or if I want to embrace this like sort of state machine thing that I was sketching out. I think this is the way to go, because this is also going to push me back into refining the script, the C scripting stuff. I think pushing farther on the capabilities of C scripting makes the most sense to me right now, and we'll keep an eye out to all the stuff we want to do with object files down the line to clean up some of the issues that this is creating. But I don't want to go down that path yet, because I haven't actually pushed this to its limit either. So I think that's it for today, with the idea that tomorrow I'll get back to the RPG simulator, I think. So that's cool. I'm looking forward to that. Anyways, if you've been following along today or the last couple days, then thanks for coming around, and I'll see you around the internet.